Welcome back to another flight computer video. Today we are looking at the Cox and Stevens Aircraft Corporation load adjuster. Now, load adjusters were made for many different models of aircraft. Here's an example of one for the C-123. And what we'll be talking about today is the one for the C-47, or the military version of the DC-3, the Douglas DC-3. So it's not a flight computer per se, but it was used for the same common goal as flight computers, which is avoid doing multiplication and division by hand. And when you're doing a weight and balance calculation, it's not all that complex, but there are two formulas that you work through. Weight times arm gives you a moment, and then the center of gravity for the aircraft is the total number of moments divided by the total weight of all the things that are in the airplane. So you can see we have a multiplication and a division here, and thanks to our load adjuster, we won't have to do those by hand. So first thing to say is that it came in a very nice leather case, and this was designed to be kept in the airplane and used by whoever was responsible for the load calculations. The slide of this device has two sides with different scales on it. And the stock or body of the slide has information about the forward and aft limits, an index scale, which is linear, as well as a diagram of the airplane on the back and the different sections for loading it. So to learn more about this, we'll go ahead and walk through an example problem. And this is what we'll be doing. So we'll be taking these calculations, and everything here has already been added up. So if we look at our problem at hand, we've got an empty weight of the airplane plus the weight of everything that we want to load into our C-47. And what we'll be doing is we won't have to calculate any of these moments. The load adjuster will do that for us. And our first question is to find the empty weight index. So there's some instructions here on the device about 3 steps to do that. So the first step is to set the weight to arrow at the 0 index. So our empty weight is 19,850 pounds. So we find that here on this scale, which is right about there, 19,850. And the next thing we do is we move our indicator to the moment divided by 1,000 line. So our moment divided by 1,000 is 500. So we slide our cursor on down to 5,000. And this gives us our empty weight index at the bottom of the slide, which looks like 37.8. So that will be the answer to our first question. Now, the index number is going to be different for every load adjuster. There's a formula here if you're interested in going back and forth between center of gravity units and index numbers. That's right here. But we will just carry on and get to loading our airplane and solving our next question, which is we got to find our aircraft center of gravity with our fuel. So what we do here is, notice our index number hasn't changed. It's still 37.8. We start adding things to the airplane. So we'll start with oil, and we'll add 50 gallons of oil. Now, the way we do this is we bring the oil line right there, where it says 0 gallons of oil, to the cursor, and then we move the cursor along to however many gallons of oil we have, so 50 gallons of oil. So I slide it until it reaches 50. And there, you can tell we've adjusted the index forward because the oil would have been forward of the center of gravity. Now we'll add forward fuel. We'll add 300 gallons. So again, same process here. We slide the forward fuel, or the wing front scale, to the cursor, and then we slide the cursor to add the fuel into place. So there, I've added 300 gallons, and we'll do the same thing for the rear fuel. So we've also added 300 gallons in the back of the wing. So we slide that back like this. All right, moving along, now we'll go ahead and put the pilots in. So the pilots, where do the pilots sit? There's no scale for pilots here. To get that, we have to flip the device around, and we look and we see that the pilots are in section A. And the pilots weigh 400 pounds. So what we do is we set the compartment loads line of 0 there on our cursor. And in section A here, we slide our cursor down to 400 pounds. So that adds our pilots. Then we have our navigator and our radio operator. They sit in section C. So we'll add 400 pounds to section C. Again, we slide the 0 mark to be under our cursor, and then we put 400 pounds into section C, like so. And moving right along, the next thing is we're going to carry some fuel in the cabin. We're going to carry 200 gallons in the cabin. And if we look here on the back, we can see that when we go with that configuration, that will be in section D. So we could add that weight here as a compartment load in section D, but we actually have some helper functions over here for carrying cabin fuel. So what we'll do is we'll set the 0 line under our cursor. And for tanks 1 and 2, we'll put in 200 gallons, which is lined up right there. Now you can tell that our center of gravity has moved far forward as we've loaded the front of the airplane, but now it's time to load the back of the airplane. The next thing that we're adding is a Jeep. You might think, how are you going to get a Jeep inside a C-47? Well, it certainly was possible. Here's a nice picture of it. It's barely fitting through those giant doors, but according to the back of the device, if you do want to load a Jeep, you're going to have to do that either in section D or in section E. And since our section D is full of fuel, we'll put the Jeep in section E. So we slide the compartment loads 0 line down to our index. And for compartment E, we want to add the weight of our Jeep, which is 2,450 pounds. So that slides the center of gravity pretty far forward back. And the last thing we want to do is add 2,000 pounds of cargo, and we'll do that here in section F. So again, bring the compartment load to the index, and then add 2,000 pounds here in compartment F. Okay, so now that we've added all the loads, we have our center of gravity, and we're nearly at max gross weight here of 3,100 pounds. And our center of gravity with full fuel would be about 260 inches, which is right at the aft limit. In fact, it's probably too close to the aft limit. One of the notes that we have on here is to make sure that we check expenditure of fuel for landing. So let's just walk through that before we record our answer. What's going to happen as we're flying along and we burn off, let's just say we burned off all of our fuel. So to do that, to simulate that, we would put our 300 gallons of fuel back here on the index and erase it. So we take that fuel out, and we do the same thing for the wing front. So 300 gallons that we had in front, what's going to happen when we burn all those off? Well, now when we look at our center of gravity, you can tell we're behind the aft limit, which is not good. We haven't properly loaded this aircraft. So let's go ahead and put that fuel back where it was. So just going to add 300 gallons in the front and 300 gallons in the back, which again has us pretty close to our aft limit. And let's see, what could we do? How could we bring some of this cargo forward? Well, if we flip and we look at the diagram of our airplane, we'll see that we can actually put 400 pounds in section B. So why don't we take 400 pounds out of F and bring it forward to section B? To do that, what we would do is find 400 on the F compartment load, which is right there. I'm going to take that out, so I bring that back to 0, and then I add it to the B section. And when I do that, now I've got a center of gravity that's nicely in the middle of my range. So it looks to me like it's about 259, maybe 259.1. So that's a better loading of our aircraft, 259.1. And the last question here is to, again, find our aircraft CG with 0 fuel. So we would do that same process again, where we take out our fuel. So we take 300 out of the rear tanks and 300 out of the front tanks. And we check our center of gravity. And that is going to be pretty much the same. So if we follow this in terms of our weight, we've just lost 3,600 pounds. It's going to be right around here. So still about 250, I'd say maybe 259.3 inches will be our center of gravity there. So that's how the load adjuster works. We can see how to load an airplane, how to shift weights, and how in doing all of that, it wasn't necessary for us to do a single multiplication or a single division. Now we did have to add the fuel weights together, but longhand, adding multiple 4-digit numbers is not nearly as complicated as multiplying a bunch of 4-digit numbers. So that's all for this video. If you're into nomograms and interesting flight devices like this, you'll have to come back to check out the next video where we talk about another such device. That's all for today. Thanks for watching.